Alright, mock exams aren't far away, so let's try a question a day. We got the integral from pi over 2 to 0 for the function sine 2 pi over 1 plus cos theta, d theta equals 2 minus 2 ln 2. So, what we're going to do is, when I initially saw this question, I thought to use u substitution. So, I wrote sine 2 theta using the double angle formula as 2 sine theta cos theta. And I use u equals 1 plus cos theta and u minus 1 equals cos theta. Now, I knew that d theta could be cancelled if I differentiated the u minus 1 with respect to theta, because that will give me du d theta equals minus sine theta, and d theta du equals minus 1 over sine theta. That's just a reciprocation of that fraction. And therefore, d theta is equal to 1 minus 1 over sine theta du. So what I can do now is I can substitute this d theta for minus 1 over sine theta du. And I can also let u equal 1 plus cos theta. So, because I've done that now, I can say that u is equal to 1 plus cos pi over 2 for the limit. So the first limit will be 1, and u equals 1 over cos theta, and that should equal 2. And there's nothing wrong with that. You can have your limits like this. So I'll keep my limits like that, and I'm not going to move them. So, integral from 1 to 2 for 2 sine theta cos theta times negative 1 over sine theta. So we can cancel out the sine thetas, which is the whole point of the substitution. And then cos theta over 1 plus cos theta, well, I can just use a substitution. Actually, 2 cos theta over 1 plus cos theta du. Now I can use a substitution. And you can see that I've taken the negative sign out the front of the integral. So that just means when I get my answer, I'll just negate it. So cos theta equals u minus 1. So I can substitute 2u minus 2 all over u, because 1 plus cos theta is equal to u. Okay, and now it's just 2u minus 2 over u. So we can split the numerator into 2 separate fractions, 2u over u, which becomes 2, and minus 2 over u, which becomes negative 2 over u. So what we need to do now is integrate it. So I get 2u, because I increased the power, and then negative 2 over u is the ln type, so it becomes minus 2 ln u. Then I got to substitute 1 and 2, the limits, and by substituting them, we get to this form right here, 2 minus 2 ln 1 minus 2 times 2 plus 2 ln 2, and then we negate the whole thing because we have a negative out the front of the integral. So negative 2 at 2 ln 1 is just going to be 0, because any ln 1 is 0, and then 2 times 2 is 4, and then minus 2 ln 2. So if we simplify it, we get 2 minus 2 ln 2, which is exactly what they wanted us to show. Now, with practice, you'll be able to see it, but I think what gave it away was the fact that 1 plus cos theta was just in the denominator, and because this was in the denominator, I just made that substitution, and I knew that eventually I'd get a sign which would cancel out because of that d theta over there. So with a bit of practice, you'll start to see these substitutions quickly. So I'll see you in the next video. Peace.